Hi there, and welcome back to this channel. In today's video, we are going to be discussing sequence and series. You see, sequence and series are two terms that mean that relates to the same thing. Now, what is a sequence? Sequence is basically an order of a set of numbers that proceed in a regular pattern or a regular order. Now, it could be with respect to addition and subtraction or with respect to multiplication and division. And that is what separates the two aspects of sequence, all right? And a series is basically the sum of all of these items. So, for example, let's make sense of that. If I have 0, 1, 2, 3, 4, 5, 6, unnatural numbers, this is a sequence. Why? Because it proceeds in irregular order, making sure that every item or consecutive items differ by 1, 1, 1, 1. And you see, that term differ is one of the terms that we use in sequence to account for the regularity between them. Now, it means that to get any successive term, we add, in this case, we add 1 to an initial term. All right, so that is why it is a sequence. We could have another sequence like this: 2, 4, 6, 8, 10, 12, dot, dot, dot. Now, this is also a sequence. Why? It is a sequence because it proceeds with a regular pattern. In this case, to get any successive term, you add 2 to an initial term. All right, so look at another sequence. I could have the same 2, 4, 8, now 16, 32. Looking at this sequence, you see it's different from this, although they began with almost the same thing, but they differ at the end of the day. All right, now this is also a sequence, only that this is geometric. Why is it geometric? Look at the relationship between our terms here is additive. All right, but here it is multiplicative. All right, so this is called a geometric sequence, and this is called an arithmetic sequence or a linear sequence. All right, so you can call this a geometric or an exponential, geometric or exponential, while this arithmetic, this and this arithmetic or linear. All right, let's go on to those two aspects of sequence and series. I said series simply means the addition of all of those items. So, for example, if I add all the that series sequence that I just put together, that will be called series. All right, now let's start with the arithmetic progression. Now, arithmetic progression or AP or linear progression. All right, for example, I have that same sequence that I wrote down: 2, 4, 6, 8, 10. Now, the first term here is denoted by A in sequence. So the first term is denoted by A. All right, and now if you notice from A, how did we get B? We said A was the first term was A. We added 2 to it to give us 4. Now, how did we get 6? We added 2 to give us 6. How did we get 8? We added 2 to give us 8. How did we get 10? We added 2 to give us 10. Now, what do you notice here? It means that in each case, we are adding 2, 2, 2, all right? So now, what is the difference between this and this and this and this and this? The difference is that 2, and that difference is known as a common difference. It's known as what? A common difference, because it's common among, that difference is common throughout the sequence. So it is called a common difference, unless it is denoted by D. The common difference is denoted by what? It's denoted by D. All right? Now, look at, you are going to see irregularity now. It means that, how was this, if we were to look at how this sequence was formed? Now, what do? We take the first term, which is 2. Looking at that thing that I just did here, I'm going to now use this idea here. I will no longer use numbers. We said we took the first term A and added our common difference D. So A was the first term. So we said this is, so first term, let's do it by T1, second term T2, third term T3, fourth term T4, fifth term T5, all right? Now, our T1 is A. Now, what would our T2 be? T2 was 4. But how did we get that 4? We added 2 to that A, right? To that first term 2. And our 2 was the common difference. In this case, D, right? Is denoted by D. All right. So we added 2 to it. We added our common difference to it. All right. Now, how did we get T3? T3 was gotten by A plus that. Now, A plus D was T2, isn't it? A plus D was T2. So we can simply say we got T3 by adding D to T2. So that is T2 plus D. But remember that T2 is A plus D, right? So it becomes A plus D, which is T2 plus D again. And that becomes A plus 2D. All right. Now, how did we get T4? T4 was basically T3 plus T3 plus D. We added the D, that is our 2, plus this T3, and we got our T4. So, and remember that T3 is A plus 2D, that is A plus 2D plus D, this D. And that becomes what? A plus 3D. Now, if you look at it very well, now let's get to the last one. The last one says T4 plus D, right? So what is our T4? T4 is A plus 3D and then plus what? D. All right, that becomes A plus 3D plus D. That becomes A plus 4D. Now, what did you notice? When it was T1, we had only A. When it was T2, we had A plus D. When it was T3, we had A plus 2D for T3. For T4, we had A plus 3D. For T5, we had A plus 4D. Now, what do you notice here? It means that if we want to find our nth term, a particular nth value, a particular nth term, it is going to be A plus, notice here, notice at 5, for example, when we were looking for 5, for T5, what we basically did for T5, what we basically did was to take, we removed 1 from that 5 and it gave us 4. Right? So when we were looking for T4, we remove 1 from 4 and it gave us 3. Right? So in that same case, we are going to generate a general term, a general formula for expressing our nth value. It's going to be A plus that nth value we are looking for minus 1 then times D. Let me make sense of that again. When we were looking for T2, what we basically did was to subtract 1 from 2 and then times our D. Now, to prove that, for example, we'll look for T3. T3 will be equal to A plus 3 minus 1D. That 3 here, so equal to 3 equal to A plus, this minus this is what? 2D. Now, which is equal to this guy. Do you see that? All right. So, for any particular term we're looking for, we are going to reduce that term by 1 and then add our D. And that is what it is. So, in that case, if I told you to find the T9 for me, ninth term or T9, we basically got A plus AD. If I say find the 99th term, that becomes what? T99 is equal to what? A plus 98D. Is that okay? If I say find the 1000th term, that becomes T1000 will be equal to what? A plus 999D. And that is the simple, the first trick to solving arithmetic progression. All right, let's go on to solving one question. Let's solve our first question. All right, looking at these 3 questions, the first question says, a crate of eggs contains grains of corns. The first hole contains 3 grains. So the first hole, in the first hole, we will find 3 grains. So the second hole will find 5 grains. The third row will find 7 grains. All right, this seems to be to look like AP, isn't it? Because of there is a form of regularity. So it means that each hole, each successive hole, is differing by what? 2, 2, 2. Looking at it. But let's say we don't even know. Now, how many grains will be in the 7th hole? There are 2 ways to go about this. Now, the first thing is to check for the A, which is the first term. What's our first term? Our first term is 3. And now, what is the common difference? Now, how did we get common difference then? By simply taking any 2 consecutive terms and subtracting them. So if I subtract this from this, 5 from 3, for example, I'll get 2. Or T3 minus T2, right? That is 7 minus 5 is equal to what? 2 still. So our common difference is basically subtracting any 2 consecutive terms. So I've gotten my common difference of what? To be 2. Now, how do I find my 7th term? There are 2 ways. The first way is to basically say that T7 is going to be what? Remember that we generated the formula there that Tn because A plus n minus 1d. So it becomes T7, right? So it becomes A plus A in our case is 3 plus n, which is 7 minus 1 times d, which is 2 that we obtained. So we have T7 is going to be 3 plus 7 minus 1, 6 times 2, that is 12. So that T7 is equal to 15. Now, or you could just go directly by saying, now remember that we just said, we gave a shorter method of saying whenever you just hear the term, you can just derive the formula. In an AP, you can know the formula. So T7 is going to be what? A plus 6D. All right. So what is our A? 3 plus 6D is what? 6 times 2. And that is what? 3 plus 12, that is what? 15. Now you see this is shorter rather than beginning to plug in values here. So once you hear the term, you can easily go on to solving, plugging your values in. Generating it for a short formula and then plugging your values in. Of course, the formula is actually diminutive of this. It's diminutive of this, but it's faster. All right. Now let's go to number 2. Number 2 says that the 6th term of an AP. Now you're going to see the way our term is going. The 6th term of an AP. I don't need to do anything yet. I'll just say T6 is what? A plus 5D. Remember that's T6. Now it's said to be 35. So T6 is 35. So I can equate everything to what? To 35. Is that okay? You saw the way I interpreted it. T6 means A plus 5D. T3, A plus 2D. T7, A plus 6D. T19, A plus 18D. You get it right? So here, it says, and the 13th term. So, and the 13th term, I go, T13 is equal to A plus 12D, isn't it? It's equal to is 77, according to them. Then I'm asked to find the 20th term, all right? Very easily. Now, I'm asked to find T20. Before I find T20, let me find what my terms are, the first term and the common difference. Let me find them. All right. So, what do? I could solve simultaneously. How do I solve simultaneously? I could easily say that using elimination method, I'm going to take care of this using subtraction. So I subtract this from this, and I subtract this from this. That becomes minus 7D is equal to, that is this from this. Now I want to subtract this from this as well. 35 from this is going to be minus, and 77 from that is going to be minus 30, minus 30, minus 42. Minus 42. All right. So we can now divide both sides by minus 7. So how do I divide both sides by minus 7? I say minus 7 here, minus 7 here. And then we have 6. So D is going to be equal to 6 because negative to take care of negative. All right. So we can now plug in this value for D in any of the equations. Remember, this is equation 1, this is equation 2. All right. So in equation 1, A plus 5D is equal to 35. So I basically plug in my D value that I've obtained. So A becomes 5 into bracket 6. 5 into bracket 6 equal to 35. So A will be equal to what? A plus what? 30 is equal to 35. So what do I do from here? I subtract 30 from both sides. Here minus 30, here minus 30. So A becomes what? This minus this is what? 5. And that becomes my first term. Now, how do I find T20? Remember, T20 will be equal to what? A plus what? 19D. Just as the formula, the simple formula says. So that becomes equal to what? A, which is 5 now, plus 19 times, what do we get for D? 6. Alright, so 5 plus 19 times 6, that is going to be 4, that will be 114, I think. Then 104 plus 5, that becomes, let's do this again. This by this, that is 54. Then plus this by this 655. So we're going to have 9, this plus this becomes 119. All right, and that becomes our answer. Okay, so let's go on to the next question, which is this number 3. All right, I'm going to clean this space to solve the number 3. Now, number 3 is not technical at all. It only looks technical. All right, now it becomes the first 3 terms of an AP. So this one says, number 3 says, the first 3 terms, we have x, 3x plus 1, and 7x minus 4. These are the first 3 terms of an AP. It says we have to find x. So this is T1, T2, and T3. All right, now we cannot just go directly to imputing a plus 5d here. Why? Because we already have unknowns here. But look at what I can do. One thing I can do. I know that my first term is a, right? Now, how do I get my common difference? My common difference is this minus this, or this minus this. Now, knowing fully well that if I subtract this from this, I'm going to get the same answer as subtracting this from this, isn't it? When I subtract any 2 consecutive terms. So I mean that if I say 3x plus 1 minus x is the same as 7x minus 4 minus 3x plus 1. I hope this is clear. That if I subtract this from this, and this from this, or this from this, I'm going to get the same answer. So I equate them. And that becomes 3x plus 1 minus x is equal to 7x minus 4 minus, we open the bracket, so we have 3x minus 1. Is that clear? So that we have 3x. I can use this to subtract this. That gives me 2x. So that's 3x minus x. That's 2x plus 1 is equal to 7x minus 3x. That's giving me 4x minus 4 minus 1. So I'm left with a constant and a few x's. All right, what do? I can subtract, I can collect x's to this side. How do I collect? I bring this x to this side by 4x to this side by subtracting 4 from both sides. So I have minus 4x here and minus 4x here. Now, 2x minus 4x, what does that give me? That gives me minus 2x, all right? And this one becomes 0. So x has left here. Now here, to remove this guy from it, I basically subtract it from both sides too, because it's being added here. So if you don't understand that concept, please go to my video on change of subject or formula. So you understand why I am doing it this way. So you simply do the opposite of what is being done to it here. That is plus here, so you subtract from both sides. Minus 1, minus 1. Here it turns to 0, and it will be equal to, therefore, minus 4 minus 1 minus 1. That becomes what? Minus 6. Minus 6. All right, then we can now divide both sides by minus 2. So minus 2, minus 2. All right, minus 6 minus, and x becomes what? 3. And that becomes our x. So we have found x now. Now the next question, the second question says, so this is the first question. The second question says we should find 10th term, as T10. So what is T10? T10 is going to be what? T10 is going to be the A plus 9D, what we used in that case. A plus 9D. All right. Now, first, have we found our A? Let's see. X is A, so it means that A is, so A is what? 3, because X is A. All right. Now, how do we find our D? So we can now find our D from using subtraction of any of these two, isn't it? All right. So how do we get D? D is going to be equal to 3x plus 1 minus x. We can subtract any of this. So, but now we know that our x is 3, right? So we can basically say that D will be equal to 3 into brackets 3 plus 1 minus 3. So that we have D equal to 9, 3 by 3, 9, plus 1 minus 3. So we have 3 minus this was this 10 minus this equals 7. So we have 7. All right, our D is 7. So we go back to our equation. So A plus 9D, which is T10, is going to be A, which is now 3, plus 9 into bracket 7. So that we have T10 to be equal to, how do I put this? Let's put this here. So T10 is going to be equal to 9 by 7 is going to be 63 plus 3, that will be 66. And that becomes our T10. All right, let's go on to the sum of an AP. Now, the sum of an AP is given by a formula, and the formula is Sn, which represents sum of AP, is equal to n over 2 into bracket 2a plus n minus 1d. Now, this is the formula, but there is a mathematical trick that I could teach you that you can use to find the sum of an AP. All right, let's go on to the mathematical trick. So, for example, if I asked you to find, if I give you a sequence like this, if I give you like 2, 4, 6, 8, 10, for example, 12, for example, and I asked you to find the sum of this AP. Now, what this means is you should add up all of this. Now, let's add it up. Let's see what it's going to give us. This plus this, 6 plus 6, 12 plus this, 20, 20 plus 22. This becomes 42. All right, let's see if we can get this with a trick. Now, the trick I'm going to teach you is this. What you basically want to do is, let's rewrite this from the back. This becomes 12, 10, 8, 6, 4, 2. So I've written this expression from the back. Now, what do? You are going to take the addition of this, the scalar addition of this, and 2 plus 4, 12 gives you what? 14, isn't it? Times, how many items do you have here? I have 1, 2, 3, 4, 5, 6 items. 6 and divided by 2. It's always divided by 2. All right. See what I did? I basically added this and this, or this to this. Either way you want to take it. This to this. This gives 14. Then times how many items do I have? I have 6 items divided by 2. That becomes here 1, here 3. Now 3 times this gives us 42. So you see the trick works. All right. Let me give you another one. Let's say I told you to find what if I told you to find the sum of the first, from 1 to 100, find the sum of the prime numbers between 1 and 50, or even number. Let's use even number and odd number. Let's say the sum of the odd numbers between 1 and 50, for example. Okay, so odd number, that is, those are 1, 2, and 1, 3, 5, 7. Okay, so let's do that. So, for example, I have 1, 3, 5, 7, 9, Now, if we are taking it between 1 and 50, what will be the last one? We're going to take between 1 and 99 as well. So, but if we want to take between 9 and 50, it means that the last one is going to be 49, right? Now, see this. I don't want to write the entire thing because it's going to be too much to handle. All right. So, but look at the trick now. So, what did we do here? We said we are going to add this first one and this last one because we want to rewrite this from the back. It's going to be 49, 47, 45, 43, 41, 1, isn't it? All right, so I'm going to add this, and it gives you what? 50. Now, 50 times, how many items am I going to have? How many items am I going to have? What I will have is, between 1 and 50, half will be odd and half will be even. So what does that mean? It means I'm going to have 25 items. And we can try that. We are going to have 25 items. I said it's always going to be over 2. So 2 here 1, 2 here 25. And 25 times 25 is what? That will be 625. 625. That's 125 times 5. That's 625. All right. So you see the trick works. If I wanted to do between 1 and 99, what would I do? I'll basically add 1 and 99. And that gives me what? 100. So 100 times, how many items am I going to have? if I was taking only the odd numbers between 1 and 100, I'm going to have 50, because 50 will be odd, 50 will be even. So times 50 all over 2. Here 1, here 25. 25 times 100 gives us 2500. Is that okay? So that is a mathematical or numeric trick, all right? Now, what if we now wanted to use the formula approach? So notice, this formula actually looks like the other one that we used the other time. The formula looks like the one we used the other time. Remember that the sum of the nth term of the GP, recall that nth term, Tn, is equal to a plus n minus 1d. Alright, and this is also called the last term. So if I want to find the last term, I'll use this formula. So if I'm looking for the last term with this, and if you look at this equation vividly, I can adapt this from this. So this becomes Sn equals to n over 2, open bracket. Now, if I adapt this from this, it basically means this was a plus this. So if I adapt the entire thing, I'm going to be left with only a. So a plus, and this is the last term, a plus nth term or last term. This is another formula. All right, let's solve one question using this formula. I think I have a question here. This question says, all right, let's solve this first. This two questions on sum of GP, on sum of AP. It says for an AP, the first term is 5. So for a particular AP, we have the first term A is 5. And the common difference is 7. D is 7. Find the sum of the first 13 terms. So we have S13 is what we're looking for. So and recall that Sn is equal to n over 2 into bracket 2a plus n minus 1d, isn't it? All right, so what do we do here? We basically plug in our values. S13 will now be equal to what? 13 over 2 here into bracket 2 into bracket a, that's 5, plus n, which is 13 minus 1 times d. What is our common difference? 7. All right. Okay, so S13 therefore will be equal to 13 over 2. Now, I will not put this as 6.5 yet, because I could have a value that this thing might be able to cut. I don't know yet, but let's go on. Now, multiplied by 2 plus, actually, okay, 2 times this plus this. Okay, so this becomes 10 plus this minus this is 12. 12 times 7, that is 6 times 7, 42 times 2, that is 84. 84. So I have this. So I have S13 equal to 13 over 2 times 10 plus this becomes 94. So you see I can actually use 2 to cut this. So 2 here 1. 2 in 94 is going to give me 47. Alright? So 47 now times 13. 47 times 13, S13 will be equal to 47 times 13, 470 plus, that will be plus, that becomes 611. Alright, so that becomes 611, and that becomes our answer. Just use your calculator and do 13 times 47. That becomes. Alright, with this we come to the end of this video, and if you did gain value, do like and subscribe to this channel. Also share the video with your friends that you know might need the video, and I'll see you in the next video. And until then, keep winning. Thank you very much. But before you go, make sure that you solve this number 2 as an assignment and drop the answer in the comment section. So you go on with this. The sum and product of the first 3 terms of an AP are 3 and minus 15 respectively. Find the numbers. See you in the next video. Thank you.